Right, guys, so now I want us to look at the nth term of a quadratic sequence. You know, when we talk of a quadratic sequence, it means the formula is n squared somehow, right? So the general formula of a quadratic sequence is a n squared plus bn plus c, where a is not equal to 0, okay? A is not equal to 0, because once a is equal to 0, then that means everything else ceases to be a quadratic sequence, right? So now what we need to remember are these formulas that I've put down here, okay, for us to find the nth term of a quadratic sequence. So first of all, we have to equate 2a. For us to find a, we say 2a is equal to the second difference. You'll see the common difference once we do the example there. Then 3a plus b will be always equal to the first term of the first difference, and then a plus b plus c will be equal to the first term of the original sequence. So I have numbers here: 3, 5, 9, 15, and 23. So the first thing that you do if you're looking for the nth term, you're subtracting, right? 5 minus 3, there you get 2, right? 9 minus 5, you get 4, and then 15 minus 9, you get 6. 23 minus 15, you get 8 here. You get 8. Good. So you can see that these numbers, they don't look the same. So automatically you cancel out, you already rule out that this is not a linear sequence. So we can move on to subtract again these numbers. So this is what you call the first difference, okay? In case you're wondering what I was referring to when I said first difference up here, if you check the first difference, that's what I meant by the first difference. So this is the first difference. These all these numbers, they are in the first difference. Right, now let's do the second difference. So I'm subtracting, what is 4 minus 2, we get 2. 6 minus 4, we get 2, and then 8 minus 6, we get 2. So this now is the second difference. This is the second difference. Very good. So you can see that all these numbers, they look the same now. So once they get we get to a point where these numbers look the same on the second difference, then it means it's a quadratic sequence that we are dealing with. And that's what we call the common difference. In case you're wondering what I meant by a common difference, that's what I meant by the common difference up there. So for us to get the value of a, what we are simply doing, we are saying, right, okay, we'll move down there, move down to the next page. Right, so we're going to say, right, 2a is equal to 2, right, which is the first term of the common difference. That's what I'm actually referring to. Oh, you can just say common difference is still okay for that one. Okay, I'd written the formulas up here that 2a must be equal to the second difference, which is the common difference. So 2a is equal to 2, right? From here we can see we can divide by 2, divide by 2, so a is equal to 1. Cancel all those, right? Next we are saying, right, for us to get the value of b, 3a plus b is equal to, right, I said the first term of the first difference. So the first term of the first difference is 2. It's a coincidence, by the way. It's not always 2. They are not always the same. It's just a coincidence that we have 2 there. So that is equal to 2. So that means we are saying this is equal to 2. Now, once we have 2 there, we substitute. We got the value of a as 1 plus b is equal to 2. So that means we have 3 plus b equals 2. B is equal to 2 minus 3. So b is equal to negative 1. Good. Then finally, for us to get the value of c, we say a plus b plus c is equal to the first term of the original sequence, which is what? The first term of the original sequence is 3 up there. It's actually 3. That 3. Okay, fortunately this is misbehaving, but anyway, it's fine. So now we are saying we are substituting our values, so we're going to equate that to 3 here. So a is 1, b is negative 1, then plus c equals 3. You can see that these two guys will give us a 0 here, right? So that means our c value is equal to 3. Okay, So once we get the value of A, the value of B, and the value of C, then it means we can now say, right, the nth term Tn is equal to an squared plus bn plus c, all right, which is equal to n squared. I don't know if you want to write 1 there. Minus 1n and then plus 3. And then this is simply n squared minus n plus 3. This will be the nth term. Okay, that's how you find the nth term of a quadratic sequence. I hope you got something from here, and I hope you always follow my channel and subscribe. Thank you so much for watching. See you next time.